Hello, welcome to this lecture video. So our objective today is to talk about normal distribution. So what what will we talk about normal distribution? So first, we are going to consider what are the characteristics of a normal curve or a normal distribution. Then we will also discuss how to convert raw data or normal data to z-score or standardized score. And then the last one is we are going to solve problems that involve a normal curve. So this is in computing for either proportion or probability and other related to this problem. Okay. And of course, in the, doing so, we need to discuss also how to use the table, the areas under the normal curve. Okay, let us start with the first objective. So our first objective is to talk about the characteristics of a normal curve. So how do a normal curve looks like? So let me just draw a sample of a normal curve. So this is a sample of a normal curve. So when I asked you last time to determine what is the appropriate measure for your data, given, for example, that the data is at this interval, one consideration is that we need to check if the data is normally distributed or not, especially if it did not satisfy the conditions of what they call this a central limit theorem. Okay, so in doing so, there are several ways for you to determine whether your data is normally distributed or not. So you are doing that for you to know if the appropriate measure is either mean. If it is normally distributed, it is mean. If it is not, you're going to use median. That is for the case of at least interval. Okay, so now I mentioned in that video that you can use or you can draw the curve or rather the histogram and try to draw the curve using the histogram. So if you came up with, let's say, a graph later that shows like this. So these are all the possible, these are some rather of the possible graph of histogram that you might encounter, or graph that will also look like this. Okay, so we have here figure 1, figure 2, and figure number 3. So this is our sample histogram. So if we're going to draw curves here, so the first curve, it will look like this. The second curve and the third curve will look like this. Okay, so for figure 1, obviously it does not look like a normal curve simply because this is a positively skewed. And then our next figure is negatively skewed. And our third figure is a normal curve. So in a normal curve, we have one highest frequency. So we have here one highest histogram. So if the graph looks like this, our histogram look like this, then we can say that the data is normally distributed. So as emphasized, so we have the number one characteristic of our normal curve. So number one is that it is unimodal. So because it has one highest frequency. So we also explained that if the number of frequency, for example, is highest frequency is 2, we call that as bimodal. If 3, it is trimodal, or in general, if it is 3 or more, we can actually call it as multimodal. Number 2. So let us draw histogram here. So aside from, or rather our normal curve instead. So assuming that this is our normal curve, as mentioned, the highest frequency is located at the center. So aside from the first way of determining whether our data is normally distributed using graph, we can also use the values of the mean, the median, and the mode. So let us just remove this. And since the highest frequency is located at the center, so mode is also located at the center. So in our explanation last time, if the mean, the median, and the mode is approximately equal, the data is also normally distributed. So which means the mean, the median, and the mode are located at the center. So we have the mean, median, and the mode. So if it is approximately equal, we say that it is normally distributed. Or if, of course, it is a perfect normal curve, then the values of the mean, median, and the modes are the same. So number 2, the values of the mean, median, and mode are the same. And our graph is symmetrical. So it is symmetrical. So the left side is the same as the right side. And then number 4, it is also the area under the normal curve is 1. So the area here is 1, which means half of it is 0.5 and another half is 0.5. If we're going to convert it into percent, so it is 100% or 50% on the other side and 50% on the other side also. So this is 0.5 and 0.5. So the total area is 1. And let's have number 5. So what is our number 5 value here? So aside from that, if you notice when we draw our graph, even if I'll change our drawing here, so just to show you, even if I'll change our drawing, I will still draw it this way. I will not let the curve intersect or touches the x-axis, because our number 5 characteristic is that it is asymptotic to the horizontal line. So if I extend our chart or our curve to the left or to the right side, it will never touch the horizontal line or our x-axis. So this is the five characteristic of our normal curve. So number one, it is unimodal simply because the highest frequency is 1. And it is located at the center. That's why the mode is located at the center. And if it is approximately equal with the mean, the median, so we say that it is normally distributed when we are identifying if the data is normally distributed or not, which also simply means that if the values are the same, the mean, the median, and the mode are the same, then our data is normally distributed. The curve is normally distributed. It is symmetrical with respect to our y-axis. So y-axis serves as the mirror of the left and the right side. And the area under the normal curve is 1. So which means since it is symmetrical, if you're going to divide our curve into 2, it means that half of it is 0.5 and another half is 0.5. Another characteristic of our curve is that if we extend the curve, the tail on the left or either left or right, it will never touch our horizontal axis or horizontal line because it is asymptotic to the horizontal line. Okay, so how to compute so the next, what do you call this? For our next objective, so we will compute for the z-score. So how will we use z-score? The formula for z-score, so this is our formula. Z is equal to x minus mean all over the standard deviation. So you can already compute for the mean. You know how to compute for it. You also know how to compute for the standard deviation. So given the following score, so let us convert it into the standardized score or z-score using this formula. So assuming, for example, that your score in math, this is your score in math or grade in math is 92 and your grade in science is also equal to 92. So you are provided with the data like what is the mean score or mean grade in your class. So what is the mean here? For instance, the mean is 85. While for the mean in science, so let's place sub M and sub S. The mean in science is 87. So with the standard deviation of, let's say it is a 5, standard deviation of 10. So you are provided with this data. So you know your grade. Your grade in both mathematics and science is 92. But the average grade of the class, including you of course, is 85 in math with a standard deviation of 5, while in science it is 87 with a standard deviation of 10. So let us convert 92 using our formula. Okay, first, let us compute for math. So using mathematics score, it is 92 minus the mean is 85 all over a standard deviation equal to 5. So let us compute for that using our calculator here. So 92 minus 85 over 5 is equal to 1.4. So our z is equal to 1.4 if our computation is using the given in mathematics. Now, let us also compute for science. So we have to change the value for the mean and the value of the standard deviation because, of course, the data is not the same. Okay, so what is the score or rather the mean in science? It is 87 and the standard deviation is equal to 10. So computing for that value, so let us see what will be the result. 92 less 87 divided by 10 is equal to 0.5. So let us change this value. This is 0.5. So the standard score for science is 0.5. Now, if we will, it's 1.4 and 0.5. So if we are going to, if we will locate this in our normal curve, so let us do that. Let us remove first our data here so that we can draw our curve. So let's remove it. Okay. Okay. So in our normal curve, this is our normal curve. 0.5 is located at the right side of. So anyway, another characteristic of our normal curve is where is the positive z-score located and where is the negative z-score located. So at the right side, so this is the right side, the z-score is positive, while on the left side, the z-score is negative. Our z-score at the center is equal to 0. So if we will plot this in our curve, 1.4 is above. So this is 1.4. And 0.5 is, of course, a bit nearer to the value of our 0. So we have 0.5 and 1.4. So higher, of course, is in math. So this means that you performed better in math than in science because the standardized score or the z-score is higher than your score in the standardized scores in science. And what is the meaning of this score? So this score, it means that 92 is 1.4 is standard deviation away from the mean. So let us okay, so let us clear. Okay, next. So let's go back to our 1.4. So as mentioned, this is, it means that it is 1.4 away or above. 1.4 is standard deviation away or above the mean. So why did I say that the score 92 in mathematics is 1.4 standard away from the mean? So because, for example, so using our data here, so we have 92. For us to compute for the values of the score in the standard deviation 2, this is actually adding the standard deviation. So if the standard deviation is a 5, so in our given it is a 5. If this standard deviation is equal to 5 and the score is 85, so let me erase that. So if the mean is 85, if the mean is 85 and the standard deviation is 5, it means that one standard deviation from the mean is 90 and then 95. So you will just add plus 5 because the mean, or rather the standard deviation is equal to 5. On the other hand, if we will move back, So this is minus 5. It is 80 minus 5. It is equal to 75. Which also means that if we are going to compute for the value of the standardized or the z-score of the mean, if the mean is the same with our x, so it's 85, then it means that the answer is also 0. So let us do that. Let me bring back our curve. So computation for the mean. So z, if the mean is 85, and the score is 85, the mean is 85, all over 5, of course, you will get 0. So z score here is 0. Z score for 90 is 1. Z score for 95 is 2. Z score for 80 is negative 1. Z score for 75 is negative 2. So you can actually recompute for that. So just to show you, so let us erase our board. So for z is equal to 90, 90 minus 85 over 5 is 5 over 5. It is equal to 1. For z equals 95 minus 85 over 5, you will get 2, and so on. So here,